And I've seen very few about development scripts or actual how to build these things, right? And this is what inspired me to put together this talk and share my ideas, how I have been using developer scripts in some of my past projects to kind of standardize the way how several teams will be building multitude of microservices without going crazy. So I will start off with a really bad slide with a Wikipedia quote, but I think it has carries some really important thoughts. So one of those thoughts is that standardization is about developing technical standards. It's not just taking a big standard document that's out there and applying that to a project. It's also possible to develop and build your own standards in a way. As you can also see, standards that are developed are based on consensus of different parties. So it usually never works if you take a standard and try to apply that to a team or to a process. The same applies with development process. You cannot just force development teams to start doing something. You need to have a consensus on all parties for all development teams, and then these changes can happen. And from the second sentence, I think the crucial part is that realizing mutual gains is possible only when making mutually consistent decisions. Basically, what that means is that if you have a standard out there, or if you have a piece of code, a commons library. Yeah, just turn that down a bit. Like a commons library or a development script, then it won't be really useful unless all of the teams are using it. Okay, so what's the gains of this thing for software project? I have kind of divided these gains into three different distinct groups. So one is development, performance, and experience gains. If I pin out here that scalability of services and teams is kind of the gain of standardization, I mean that now more than ever, we want to scale our development by teams as well. So people are changing positions. So we want to construct new teams ad hoc. People want to change their projects they're working on and not only work on the single microservice for a really long time. And if there are unified way of doing things, it's much more easier to kind of change your project or onboard new people. In terms of maintainability, it's not only about making sure that your application is up and running, but it's also slightly about discoverability, how you know that all of your services are under monitoring. And this links into to another group of gain, transparency and trustworthiness gains. So if you have certain standards in place, how you build, publish, and kind of even name your microservices, then it helps a lot to observe and discover these microservices in a larger context. And it also helps us to know that the data we have, that this is useful and kind of up to date. So it's not only about reliability of our own microservices, but also reliability of data. It's really important to know that if we see a list of services running in our, I don't know, pre-live environment, then this is actually a valid list. And the third kind of group or category is security gains. As microservices have larger surface area in terms of kind of touch points or security, a possibility for security vulnerabilities is bigger because the surface area is larger. You have larger variety of libraries brought in, different kind of, if the way how you build your APIs is very different, then you obviously have a larger possibility for a security breach. So one way that I'm going to share to you today, and this is what this talk is basically about, is how developer scripts can help you achieve these gains, right? And I see developer scripts. If I say developer scripts, I mean something that's these are utilities basically that help you as a developer to be more efficient. You notice a repetitive action, you take action and automate it, so you wouldn't have to repeat your work again on another day. One thing that I see very often, and probably you have seen as well, maybe we can have a quick poll here and you guys can raise your hands if you can see such a deployment script or guidelines, how to set up your local development environment. You need to set some credentials to environment variables. You need to add some more configuration to the environment variables. Then you need to download a database server and spin it up, possibly populate that with test data. Then creating Docker stack or starting off a Minikube, something like that. And in your project root, you probably need to build the project and then run something like that. So this is often nowadays a command you use to deploy something even to your local environment. And to type that out each and every time is a mess. You can always use history, of course, command history, it works, but still, this is something that tends to be tedious. So what if this could be much easier? What if this could be just one step to deploy local SH? So this is you just write a script one time that pretty much does all that. So once you run it, it will try to identify if you have all the required credentials set. If not, it will ask you to set those and you can retry the script. It can then identify if the project stack, the Docker stack, is present. And if not, it can as well create that. And there will be some kind of Docker magic, the commands executed and so forth. Then it can identify that the configuration you are using is using default database connection URL, and it can ping that there is no database running at that location, and then it can start off a database image to deploy the database image to the same Docker stack, so that this would be available for the application to run. And as the last step, it will deploy the application. So this is very similar of what you would write for CI pipeline. And this is something that's very usable for and reusable for developers as well. All of microservices could use such a deployment script if you know a few aspects of about that microservice. You need to know what command you need to build that microservice. You need to know where the binary will be published, what will be the Docker image that's going to be deployed. And you need to know the name of that service. You need to pass that on for a script or inject that somehow. This is definitely something that I would use daily. I would never use kind of this local deployment, but I would use this script even for redeployments, because it's able to identify that my configuration is set up, my stack is running, my database is running, so it doesn't repeat those actions, and it will just, on consecutive executions, it will just do a deployment. So as you can see, this kind of a automatic documentation for deployment process, it can be automatically tested. It can be reused in CI systems. So your Jenkins or GitLab may do the same thing. It may run the deployment, local deployment script just to run, I don't know, integration or end-to-end tests. And you can improve this simple script tremendously. If you add in flags like recreate, that would provide possibilities to just drop the stack and recreate it from scratch, or you can provide in a flag to provide a stack name for this thing. So if you don't want to use a default stack name that's generated, or want to spin up another stack to test pull request or do some performance testing, it's there. And writing this kind of script does not take tremendous amount of time. The value gained is much bigger for you. And there are tons of opportunities where you could use such simple scripts, basically. Cleaning up Docker environments, I especially like the idea of testing a pull request locally in a way that doesn't mess up your own development environment or development. You don't need to check out any other code. You can just create a temporary directory, check out code, compile that without running tests, because those tests are already running in CI system, then spin up a new Docker stack with new database, populate that with test data, and start up the application. Once you're done testing, you can wrap everything up, because naming is consistent, and the script knows what name of stack you have, and you'll have a clean environment back again. One thing that I maybe won't recommend too much to do is creating a new modules or adding new features from a template. I know this has become really popular in JavaScript projects, where you can just kind of create a controller and it creates a lot of other scaffolding for you as well. The issue with this is if you don't use it as much, then it may become like over controlling your development teams. You may really think of the need behind this kind of such a script. But I really liked the idea of executing Gradle commands on multiple projects in a sequence. So sometimes you have dependencies between projects, and as you become more proficient developer, you find yourself doing manual testing less and less. So you probably work with unit tests, and then at some point, end of the day, you want to deploy everything and just do some manual testing as well to make sure everything is working. And if there are dependencies between modules, you may need to compile some module first, then deploy it, then go to another module. And I just, for that, I wrote a simple script that I can use in any of the microservice source code bases. So I can be in any of my microservices and execute one command and say, hey, I want to run build and deploy for microservices with these aliases. So I can even define aliases that help me to be more efficient. And it will go in sequence and run those commands. It's especially useful even if you want to verify, I don't know, a version of libraries that you use in all of your microservices. So you can just list all the aliases you have set up in your machine and execute the Gradle command that does some sanity checks or security validation. Yep. So there are a few principles that I've noticed that really help to drive success of using these kind of development scripts. You need to use familiar tools. It's if you build a CLI that nobody knows how to use, like if you're building a JavaScript-based CLI for C# developers or C++ developers, they maybe don't, they probably won't go and improve that. They may start using it, but it's really important to have the developers contribute to these things as well. So you need to use familiar tools that they understand. I mentioned before that this thing becomes, these kind of scripts become somewhat documentation for your microservices. And if your developers cannot read that documentation, then it's not benefiting too much. Really recommend using these scripts or reusing these scripts in CI pipelines as much as you can. It simplifies a lot. It allows you to test these scripts constantly. and you will get really fast feedback if something breaks. I will talk about establishing naming rules and deriving as much as possible from as little as possible with upcoming slides. So establishing naming rules or kind of standards around naming for me is one of the cornerstones of these development scripts. As development scripts, from one point of view, they drive the naming. So if you generate something from development scripts, it will generate kind of entities or objects with consistent naming. And on the other hand, these development scripts rely on naming as well. So you could write scripts that identify if your microservice has an API or if it has a front end. But to do that, you need to make sure that all the, the API source code folder in your project directory always has the same name. So you can use that as a reference and check if that directory is present, then probably it's an API microservice. Otherwise, it may be some scheduled process microservice. So you need these sort of patterns to be figured out. And scripts rely heavily on these, especially, or at least the ones that I write. On the other hand, it again kind of drives the naming. So if you generate a Docker image or build a jar file for a client library, then consistent naming there is really important for you to discover something from binary repository, for example. But if you use scripts to kind of compile all of these libraries in a unified manner, then it will be consistent naming. And what I mean by that, I'm going to show you. I'll have a brief example. So this is a snippet from a Gradle script that has a name of a Docker image set as a variable and Maven repository set up for a project. And as you can see, it uses the environment variables for credentials. The one thing that I don't like right here is the fact that binary repository URL is duplicated. And in this case, it's duplicated on the same file, but it may kind of be scattered around files. And if this changes, then, or I need to reuse that somewhere else, then I need to come here and copy paste it. And it will be scattered not only in one microservice where you can just use find and replace if this changed. It will be scattered across 20, 50, or 500 microservices. And this is where it becomes an issue. Now, one easy way to kind of remedy this is to have a variable for Artifactory URL. Right? This is and start using that everywhere. I would take this even further and have some more variables for this. So I've extracted, in this case, it's the same Gradle script, but I've extracted the project name, service name, also environment name is added here, but that's kind of debatable if it should be present in this specific script. And I've used these variables to build other variables like Docker image or how the client library is named. Now, it's really good to have these variables up in place. So if a service name changes, I can change that within this specific microservice at one place, and it will apply to other variables as well. But now I still have Docker image, for example, as a variable defined in 200 different microservices. And if I want to change the pattern, naming pattern for that Docker image, I would still need to go through 200 different microservices and fix that variable. Yeah, and the same patterns actually can be applied very much on Bash or other types of scripting as well, that you can extract some common variables. In these kind of scripting environments, it's really quite okay to use global variables. I know as developers, you often, like I as a developer, often frown on that as well. If global variables are used, you shouldn't use them either in JavaScript, Java, or .NET world. But in these kind of scripting environments, I'd say it's okay. And why it's okay? It's because the context of these scripts is rather small. So you can trace from all of your script files the entire context of that execution script. If it grows really big, then maybe it shouldn't be a script anymore. Okay, so now we have this kind of parameterized script setup. As I said, you'd want to have this Docker image shared across different microservices. So you need something that's publishing the script. You need some sort of script publication bus. And what I mean by that, on one hand, you have developer script, you have a bunch of microservices, you have all those developer scripts available for these microservices. Now, you want those developer scripts to be editable from one place. So if you do a change in those development scripts, it should be propagated to all of the microservices underneath as well, without too much of a hassle. And as I see it, you essentially have two options. If you think of any other options, feel free to let me know. I'd be really interested about some new ideas as well. So one option is to use a library. So you could have publish a jar package or some sort of library that Gradle downloads and unpacks everything to a project directory called development scripts. So each and every time Gradle runs, it can check for updates, and then unpack a new version. But you cannot update that in place. You cannot just go to a script, fix it, then commit it, and it will be done. It kind of feels a bit hackish. An option I've used a lot is using Git submodules. It's a Git built-in feature. You have all the history of your kind of microservice is present in Git repository, but you also have access to all the history of your dev scripts. And you can also go inside a specific dev script, do a fix or improvement, and then commit and push that to dev scripts repository. So that's also possible. So how does this look like in a kind of repository context? So let's say we have a coffee service for my home office. And in that coffee service, I have a directory called dev scripts. And that reference is actually it's not the regular directory. It actually references another repository. And now if I have other microservices coming up, like network service for my home office as well, then it can reference the same development scripts. And now if I do any changes within the dev scripts repository, both of these microservices can push new changes. And I can even do a change within a coffee script dev script repository, coffee service dev scripts repository, right? So I can go in there, do some changes, push it to dev scripts repository, and network service can pull it and get new version. So it's fairly easy to use these things. You just add a reference to a submodule only once with git submodule add command. You specify a branch you want to reference, and then a git repository where this submodule is coming from. I like to use, I have used here a relative path to a git repository. You can use those as well, and it helps if you're using GitLab. I think they had some sort of bug, not sure if that was fixed already, but it allowed GitLab to initialize the sub-repositories automatically much better if you used relative path instead of absolute Git repository URL. And as a last parameter, you provide the directory name you want this kind of sub-repository to lie in. Each time there is a clone, you need to initialize the submodules. That's essentially pulling the scripts inside that directory. I've experimented with ways how you can initialize it automatically as well. So if you run a Gradle script, for example, and it identifies that the submodule is not initialized, then it can execute the submodule in it automatically. But in general, the changes in your teams won't be that frequent. And I don't know, it didn't have the added value that I expected. And to update, to pull the latest version of submodule, you execute git submodule update with remote flag to pull the latest version from remote server. So submodules help in very many ways. It kind of expands what you can do with development scripts. You can standardize project build tasks in Gradle up to the point you can reuse CI pipeline definitions. So you wouldn't have to copy paste your pipeline across all of the microservices. And that's kind of, but you need to be aware that if you're using such an approach, it slightly increases complexity and your teams need to be able to handle that. So how this reuse kind of works. So how to use Gradle scripts. If you remember my coffee service and my dev scripts repository, you might have noticed that my dev scripts repository contains a Gradle directory, right? And that Gradle directory contains a bunch of reusable Gradle scripts, like Docker Gradle, for example, for everything that revolves around building a Docker image and publishing a Docker image. So all of the microservices that publish some sort of Docker image will import that script, and there will be a unified way how to build a Docker image and how to name the Docker image. Remember the Docker image variable that I used in Gradle scripts? Now that is defined in that file, in the Docker Gradle file. And it's defined only in one place. So the pattern of how to name a Docker image is defined only in one place. And it's reused from all of the different microservices. So what does that make of my build scripts? How do they look like? So the first part is actually essentially building up the build script itself, setting the build script context for Gradle. And for the first line, you can see that I'm importing or applying a Gradle file, and that's the init Gradle file. And this is actually the only place in all of the projects where this dev scripts folder name is referenced. And all the upcoming references should always use the function that is also defined in the init Gradle file, right? So that defines certain variables, certain methods and functions that the upcoming scripts can use. The dependencies part here is not important, but yeah, the first two lines is what you should focus on. Then it's a set of plugins coming in and more applying external Gradle files. As you can see, all projects get kind of reusable repositories Gradle that is aware of how to extract the credentials from either environment variables, from local parameters, and so forth. So there's quite a bit of logic in there. So you can have a variety of ways how developers can set up these variables. Yep, and this is essentially all of the Gradle file for all microservices. And you can even kind of collapse this big chunk of Gradle file imports into some microservice.gradle and just have one single part, one single apply from. But this doesn't limit developers. In Gradle, for example, there's always possibility to overwrite specific tasks. So if some microservice is built differently, they can just import the docker.gradle and then just overwrite the copy Docker files portion, so that they can add in their custom features to this task. So it's open for customization, but still standardized way of building Docker files. Now, if we come back to this dev script repository part, then you may notice that in addition to all these Gradle files, I had IDEA code style directory there as well. And we have built a really small script for this as well, that essentially makes sure that for every developer, they are using the same IDEA code style config and kind of project XML that describes the code style. So we don't need another way how to publish this. These are pretty much shipped alongside with the development scripts for all developers that are, if you build a project that already kind of overrides your local code style settings, and make sure that all developers use unified code styles and code analysis checks. Okay, so let's jump to GitLab and defining CI pipelines. Now, for my home office, this would be essentially the entire build pipeline that I need to define in all of my projects. And all of that does is it just states that I want to include 3 files. One of those will be common Java that defines maybe build, test, and kind of targets or stages like that. The other one is microservice one, and a third one is microservice frontend. And I've separated these on purpose because the first one, the common Java, is something that's very much applicable for libraries as well. So you take that and then you add some features on top of that. And GitLab microservice YAML is able to override some of the tasks that are defined also in GitLab common Java. So it can make, so it can add integration testing as part of testing, for example. And the same applies for front end. No, not all microservices have a front end. I need to add that feature on top of my pipeline. And the similar thing can be done in Jenkins, that you can import files from your project directory, and using submodules is a way how to populate that project directory with centrally managed configuration files. And one option that I've also seen is you can use URL to import these files as well in Jenkins and in GitLab. And one thing that I've seen is development teams have built entirely separate service that uses some sort of template to generate a build pipeline definition, like all of these stages, build, test, so forth, and what they contain. And each and every microservice's pipeline definition does not contain anything else than just kind of few lines that download, that access that external service and downloads the pipeline definition and then parses that and executes that. So pretty much I have included 3 lines. In their case, they would just have one URL where this pipeline YAML is downloaded. And that external service can do all sorts of magic. It can bring in additional credentials. It can encrypt these credentials, runtime, and embed those within the pipeline. I know in Jenkins there are much better ways how to do that with plugins and kind of different vaults, but this is one way how you can approach this. In the request parameter, you can take the project key and the service name, and then it can pretty much fill the blanks in all of the pipeline definitions. Yes, there was a question about GitHub instead of GitLab. I really don't know if they have such an import feature or include feature, but I know that it's present in Travis CI, GitLab, and also in Jenkins. So this is what you're looking for to include something. And one thing that's really good with what I enjoy about GitLab and the YAML syntax is the possibility for GitLab itself to overlay these scripts or these YAML files on top of each other. So once these 3 files, in my case, have been imported, they will kind of compose a single build pipeline description. And the following files can replace the functionality or overwrite the functionality of the first files. So what's going to be, what's in our dev scripts? So we have, you probably saw this directory listing before. There are a bunch of deployment scripts. You can use Docker file templates there, something that you need to publish to each and every microservice. You can have Docker image, Docker files that are constructing base images, for example. GitLab CI pipeline features, Gradle scripts, and again, a bunch of bash libraries that I won't get into right now. But if you find yourself copying a file to multiple projects or multiple microservices, then you could actually take use of submodules and publish your reusable scripting in a different way, in a way that helps you to modify these files in one and only place. Yep. So a few final takeaways, a few learnings from all of this. You should not build your standardized platform, evolve it consciously. So just, you cannot foresee everything and all the challenges that come from this. If you start off with local deployment script and Git submodules, then you're pretty much good to go. And you should see how these development scripts start building up and evolving. If you think of a feature that you could really use personally, or you really like to have, that does not mean it's a good idea to implement, as it may be not used as frequently. So you're going to have the maintenance overheads of kind of maintaining the development scripts, but not the value gain out from that. Or it may be just your personal preference to execute some scripts in certain way, and other developers won't start to use it. And that's going to be a challenge. You want these things to be published and used as widely as possible. You need to maintain the development scripts in the same way as you maintain your services. So you need to have testing in place whenever possible. If you use your build scripts or kind of development scripts in Gradle CI, in many cases, that's a sufficient amount of testing if you constantly use them. But you need to have, you need to make sure that if you use some sort of libraries, those don't get old, that the developers actually have time to look into the developer scripts and understand what's going inside those, how those work actually. And practicing strategic thinking with local focus is really crucial in these cases. What I mean by that is, if you're defining a new variable, or if you have a bunch of microservices with, let's say you have a bunch of microservices with that are built with Java and JavaScript, and then one fine day you will discover the need that you need to also publish a native image. You need to publish a native application somehow, somewhere. then that might not be the best kind of use case to make reusable. Because if you think strategically, how obvious or how probable it will be that you will have another native image that you need to publish, or native application that you need to publish later on in the future. If it's not probable, then you shouldn't make it reusable. You should evolve it one step at a time. But if you think of microservices and you will add, I don't know, a new type of microservice that's executing some sort of scheduled operations or running machine learning models, then this is probably something you're going to have multiple of. So it makes sense to think a bit about how this applies for the next 10 or 50 modules to come. And also think about how to hand over your code. I mean, the script should be handed over fairly easily, as should be easy to hand over the microservices to other teams. And what you as a developer can do to improve the developer experience for the upcoming teams. That's the question that helps you to build these further. So that's a wrap from my side. If you guys have any questions, I'm now open for those. Yes, so have I considered publishing my scripts as part of Docker images, which I then run my builds within? Not really. I mean, this very much depends on the context you do your builds with. As we do everything in GitLab, it's one-liner to initialize the submodules. Now, if we publish them as part of Docker images, that's a possibility. I think that's a good alternative for Git submodules, but that locks you into the CI pipeline world, and these scripts would be a bit more difficult to use for developers, so you would need to still use the submodules. So thanks a lot, and have a great conference.